Hello and welcome to our lesson on trig functions. What we're going to do today is generalize the trig functions that we were talking about in our previous lesson, where when we looked at sine, cosine, tangent, cosecant, secant, and cotangent, we looked at them in terms of the unit circle. And in the unit circle, we know our radius length is 1. Now, as you can imagine, when we're dealing with circles, not every circle is going to have a radius length of 1. So how do we deal with the trig ratios when our radius is something other than 1? Well, we're going to generalize our ratios. Okay, so let's say we are looking at an angle in standard position. And I'm going to draw this in here to quadrant 1. So we know that the initial side's on the positive part of the axis, but let's say that the terminal side of our angle lands there in quadrant 1. And let's say that this point, P, is the end point of that terminal side. So I'm going to call this point P x and y. Okay, because that coordinate obviously has an x value and a y value. And here's our angle theta that's being created there. So if we're looking again at the unit circle, maybe don't write this on your notes, but just to follow me for a second. We were drawing in these triangles, and we said, okay, if I wanted to write a ratio, let's say for sine, I know that the sine is the opposite over the hypotenuse, and so that opposite side over that hypotenuse of 1 means we really were just looking at the opposite side. So that opposite side was that y value, and just that y value, because dividing by 1 changed nothing. Well, if now we have a radius that is other than 1, we want to make sure we divide by that and account for it. So what we're going to say here is that, let me get rid of all this, the sine for our angle is no longer just going to be the y value, it's going to be the y value divided by whatever that radius length is. So actually let me put my triangle back in here. See, this is my indecisiveness here. Alright, so we have some x value that we travel to the right, and then we have some y value that we travel up to get to that point P, which I called xy, or that coordinate xy, which I called P. And again, the sine is going to be not just our y value divided by a hypotenuse of 1, it's going to be our y value divided by whatever our radius length is. So instead of calling this opposite and hypotenuse, it's going to be any y value divided by any radius length. So that would be the general form for this trig function, is y divided by r. Now, it's still true for the circular functions that we talked about last time. It's just, again, in that unit circle, that radius length of 1 doesn't have an impact. So similarly here, if we wanted to generalize a ratio for the cosine, cosine we generally say is the adjacent side over the hypotenuse. Here we're going to say it's going to be x over not 1, but any radius length, which we'll call r. So this is going to be a ratio of x divided by r. And then tangent doesn't change. Tangent doesn't get impacted by the radius length because it's always a ratio of y over x. So that's still going to be true. And then if you recall, the cosecant, secant, cotangent, those are our reciprocal functions, where cosecant is the reciprocal of sine. So instead of the reciprocal of y, it's the reciprocal of y over r, meaning it would be r over y. Secant's the reciprocal for cosine, so that's going to be r over x. And then cotangent, again, not impacted by the radius length, so that would still be x over y. And also remember, if we're dividing by 0, that is something that is not defined for us. So anytime we have a fraction where there's a possibility of the denominator being equal to 0, then our fraction could be undefined. So our y value could end up being 0. So this one, we want to make sure we state that y can't equal 0. Our x value could be 0, so let's go ahead and state that here. X can't be 0. Again, y can't be 0. And again, x can't be 0. Now, I know that the first two fractions have a possibility of becoming 0, but not with the radius in the denominator. Because the radius length is the terminal side for our angle. We're always, if we're looking at an angle, going to have some length for that terminal side. So we don't, again, have to worry about sine or cosine being undefined. Sorry, brain was going for a second there. But just to be clear, let's go ahead and state radius can't be 0, because it is true. When we're looking at a fraction, denominator can't be 0. Okay, so there's one more piece to this. This is, again, generalized form of our trig functions, but we want to also have an equation that we can use to figure out the length of our radius, because sometimes we won't know it. Again, it can change. It doesn't have to be 1. Hopefully you can see that in the picture we're forming a right triangle, and the three sides of the right triangle can be connected using the Pythagorean theorem. So if I wanted to figure out the distance from the origin to P, that is the length of the radius that we're looking for, again, we could say, using Pythagorean theorem, that r squared is equal to the sum of x squared and y squared. And that means if we were to solve for r, that it would be equal to the square root of x squared plus y squared. So if you wanted to know the radius length and you knew the coordinates for x and y, Pythagorean theorem is going to find that for you. Okay? So knowing this these general forms for our trig functions is going to help us solve new types of problems where we're not necessarily on the unit circle. So we're still doing similar things where we want to find exact values for these trig ratios, but again, not with angles that are necessarily on the unit circle or with radius lengths that are necessarily 1. So let me show you an example. Let's try to find some function values of specific angles. So number 1, it says the terminal side of, oh man, I made a typo and I copied and pasted, which means this typo is going to happen over and over. This should say this, so sorry. The terminal side of an angle, let's get rid of that, theta in standard position passes to the point 8, 15. And then we're asked to find the values of the 6 trig functions of theta. So first, we have an angle in standard position, and it's passing through the point 8, 15. So let's try to sketch this out. I'm going to draw myself some axes here, and I have a point at 8, 15, so I'm just going to put that point out here and call it 8, 15. You can make the little tick marks if you want, but I know it's positive along the x, positive along the y, so it's going to be in quadrant 1. So if we're looking at an angle that passes through that point at 8, 15, it's going to look something like this. Okay, and based on that information, we should be able to find all 6 trig functions of theta. So let's go ahead and draw a triangle. That way this looks familiar. If I was to make a triangle in quadrant 1 using that angle, so here's again my angle that was created originally. I know that I went up 15 units and over 8 units. So the side lengths of my triangle, there's my x and my y, gives me enough information to also find my radius length. So using Pythagorean theorem, again, r squared has to equal 8 squared plus 15 squared. 8 squared being 64, 15 squared being 225, means we end up with 289. And I believe that's a perfect square. The square root of 289 is going to be 17. Let me go ahead and use the calculator just to be safe. Get rid of all this. So we have 64, we're adding 225, and then we're going to take the square root of that 289, and yeah, 17. Okay, so now I know that this length is going to be 17. So now that I have all 3 pieces, I have my x, which was given to me. So I have my x which was given to me, I had my y which was given to me, those are the coordinates I was given. Using those I was also able to establish the radius. Since I have x and y and r, I should be able to again write all 6 trig functions. So now let's say the sine for theta. On the unit circle we said sine was strictly going to be the y value because when we divide by a radius of 1 it wouldn't change. Well, now it's going to be the radius impacting here, so we're going to have our y value divided by our radius. So in this case, the y value of 15 divided by the radius of 17. Or if I wanted the cosine for theta, cosine is not just the x, it's the x divided by the radius. So we take the x value of 8 divided by the radius of 17. Tangent of theta. Tangent's my x value, just kidding, my y value divided by my x value. So I take my 15 and divide it by 8, and none of these are reducible, which is lovely. And now the last 3 are simple because they're just our reciprocals. So the reciprocal for sine is going to be cosecant. So the cosecant for theta, instead of 15 over 17 is going to be 17 over 15. So let's flip that guy over. And then the reciprocal of cosine is going to be secant. So the secant is the reciprocal of 8/17, so 17/8. And then the reciprocal for tangent is going to be cotangent, and so that's going to be 8/15. And there we are, all 6 trig functions. Okay? So got a similar question here in number 2, and if you're feeling confident and you want to try this out, this would be a good place to pause the video. Otherwise, let's draw it out just like we did before. So we have the terminal side of an angle. Again, my little typo there. Theta in standard position passing through the point radical 2 and then negative 3. So that's a positive x and a negative y, which means we're going to be in quadrant 4. Okay, let's find the value of the 6 trig functions based on that. So first I'm going to sketch this out. And I'm going to use my little cheat tool to draw this nicely. So again, since it's a positive x and a negative y, I'm going to be drawing this into quadrant 4. So let me just go ahead and make my coordinates here. Oops, draw tool still on. So I'm going to make my point in here. We're going to say radical 2, which is some decimal, it's like 1.4-ish, and then negative 3. So we went over radical 2 and down negative 3 to get to this. So that's where the terminal side of our angle is. So I'm going to draw that in. And then I'm going to make a triangle out of this, again, just like before. So if I make my triangle out of this picture, again, here's my angle that I'm looking at. We said we went over radical 2, and we went down negative 3. And now I can use those x and y values and clearly see in my picture that that's Pythagorean theorem relating those. So now I'm going to find r. So r squared is going to be negative 3 squared plus radical 2 squared. Negative 3 squared is going to make positive 9. Radical 2 squared is just going to make 2. And so r squared is equal to 11, which means r is going to be the square root of 11. So I have a radical 11 here that can't be simplified, so that's going to stay. And now again I have my x value I was given, my y value I was given. Now I also have r, so I can find all 6 trig functions. So the sine for our angle, again, that's y over r, so that's negative 3 over radical 11. And we're going to rationalize that. So if I multiply the top and the bottom by radical 11, I'm going to get negative 3 radical 11 over 11. The cosine for theta, that's going to be our x over r. So that's radical 2 over radical 11. Again, if I rationalize this, and maybe you need to see the work, sorry, maybe I shouldn't be skipping that here. If I'm going to rationalize, I'm going to multiply by a radical 11 and a radical 11. So we're going to end up with radical 22 on the top of this fraction and then 11 on the bottom. And then for the tangent, we're taking the y dividing by the x, so that would be negative 3 divided by radical 2. And we're going to rationalize this one. So we end up with negative 3 radical 2 in the numerator and then just 2 in the denominator. And now that we've done that work, the rest are reciprocals. So the reciprocal of sine is going to be cosecant. Cosecant for theta. The reciprocal I can take of either form. I think I'm going to go reciprocal of this form. Makes a little more sense, so we don't have to rationalize. So that's going to be negative radical 11 over 3. Reciprocal for cosine is going to be secant. Secant of theta. And either way, I'm going to have to do some rationalizing, so I guess it doesn't matter. Let me go ahead and take this form again. If I wrote radical 11 over radical 2 and rationalized, I'm going to run out of space. I'm going to end up with radical 20. Did I flip that? I sure did. Radical 22 over 2. Oh, I thought I was getting the same answer. I'm so sorry. Don't mind my pauses. Okay, so then the next one is cotangent. Again, reciprocal of tangent. So I'm going to take the reciprocal of this version so I don't have to rationalize once again. That's going to be a negative radical 2 over 3. Alright, so hopefully not so bad. Again, a good place to pause the video to try this out. This one is going to be a different kind of angle. It's going to make you think a little, but give it a shot. And if you're not pausing, then here we go. So we have an angle in standard position, typo, that passes through the point 0, negative 5. So let's try to sketch this out. If it's passing through the point 0, -5, that's where the terminal side of our angle is. That means it's got to be quadrantal. So 0, -5 means we're just going down -5. So that's going to be here. Oops, draw tool. Which means that is our radius, right? So our angle starts here and it's wrapping around to get to that. So we know our radius length already has to be 5. If we're going 5 units down on the negative part of the y-axis there, right? That's the length of that terminal side. So we don't have to do any Pythagorean theorem just by understanding what's given to us in the picture. We have the radius. We also have, remember, our x value and our y value. And so we should be able to write our trig ratios. So the sine is y over r, so that's -5 over 5, which is -1. Cosine, that's going to be x over r, so 0 over 5, which is going to be 0. And then tangent we take y over x, and -5 over 0, and that's where we end up being undefined. Okay, and then we want cosecant as the reciprocal of sine. So the reciprocal of -1 is still going to be -1, or think about flipping that, right? Still going to get -1. The secant as the reciprocal of cosine would end up being 5 over 0, so this one's going to be undefined as well. And then the reciprocal of tangent is going to be cotangent. So if we flip this one over, 0 over -5, well, that's going to be 0. So 0 in the numerator is fine, but 0 in the denominator, undefined. And they're all 6 ratios. Okay, so quadrantal angles a little easier than the others. We don't have to find the radius because we're just counting along our axis to get that radius. Alright, so hopefully we're feeling okay with these first few examples. Let's look at something a little different on the next one. We're still going to try to find the value of 6 trig functions, but the information we're given is slightly different. So instead of being given a point that we're passing through, number 3 says to find the 6 trig ratios if our angle in standard position, or given an angle in standard position, if the terminal side of that angle is defined by 3x minus 2y equals 0. So hopefully that looks familiar to you. You should know what that would look like if you were going to graph it. I mean, at the basic shape. And let me just show you in Desmos. If we were to graph this, what we see is a line. So the terminal side is defined by this line, but it's saying here that our x value is less than or equal to 0. So actually we're going to restrict this to only x's that are less than or equal to 0. So if I actually put that restriction in, let's make x's less than or equal to 0, then I can see that the terminal side of my angle that I'm looking at has to be in quadrant 3. Okay, so if we didn't have the calculator though, because remember we want to be able to do some of these things without technology, the first thing I want to do is graph this line because it's defining the terminal side. So if you didn't have technology to graph the line, there are lots of ways to do it. I would say an easy way to graph anything is to just make a table of values, and I'm going to use the restriction for the x's when I make my table. So x is being less than or equal to 0. I'm going to go ahead and start with 0. If I input 0 for x, 3 times 0 minus 2 times y means -2y has to equal 0, which y is going to be 0 as well. So 0, 0 is going to be a point on the graph. And then I just need one other point. So I can pick whatever I want for x, but if I put a 1 here, so 3 times 1 minus 2y equal to 0, I'm going to end up with this, right? 3 times, sorry, this is going to be subtracted over. It's going to be negative, come on, pen, -3 times 1, and then when we divide by 2, we're going to get a fraction. So I probably wouldn't choose 1. I want to choose something that's going to work out nicely. In order for this to divide evenly by 2, there's going to have to be a 2 in here. So then -2y would be equal to -6, so y would be equal to 3. So when I input a 2, sorry, since we're less than 0, let's go -2, which means this is positive and this is negative. So -2 and then -3. Okay, so I just need 2 points to make the line. We saw them happen here. You can kind of follow the graph, but 0, 0, and then I have a point here on my graph also at right here. At, maybe I can get there. I went a little too far. There it is, -2, -3. Okay, but we want to be able to do this without technology. So you pick x's that are in the specified domain here. It says the x's have to be less than or equal to 0, so just pick some that work nicely, so that's why I jumped to the -2. I actually did positive, but obviously you saw I screwed that up. So now I have this table of values, and I'm going to make my graph of my line. And -2, -3. If you want to make the markings here, you can, but there's our point. And so our angle, defined by this, passes through this point. So we're really in the same situation we were before. And that looks... I gotta do this again, sorry. That's just so terrible. I'm even using the cheat tool to draw this, and it still looked really bad. Okay, so let me try this again. So I know I'm going through the origin, and I'm going through a point at -2, -3, so I'm just going to call that -2, -3. Okay, so this is the line that I'm looking at. Oh, man. Guys, don't judge me, okay? So 3 times a charm. Here we go. This is the line that I'm looking at, but I'm only worried about it in quadrant 2, so I'm not going to... I mean, I guess I could make this go on forever. Awful. Okay, so this goes here, but all I'm going to be focused on is that little triangle because I want to find the value of the 6 trig functions associated with that angle. So I'm going to make a triangle out of the points that I have here. So let's do this. Draw this out. Again, here is the triangle that I'm going to focus on. And so here's my angle, and I went -2 along the x and -3 along the y to get to that point, -2, -3. Again, I can use Pythagorean theorem to figure out what the radius length is here. So I'm going to say r squared is equal to -2 squared and -3 squared. So that's going to be 4 and 9, which is 13. And so r is going to be the square root of 13. Can't be simplified. So there it is, okay? Now you might be wondering to yourself, because this line technically goes forever in both directions, could you use another point other than -2, -3? You absolutely could. So if I jumped to, and you don't write this on your notes, it's going to clog it up, but if I jumped to the next nice point on this graph, it would be -4. When I plug -4 in, I would have a -12, which would be added over. And then I would end up with -6, so -4, -6 would work. And if I made that triangle even bigger, right, so if I was here with -6 here and -4 here, you can see that if I'm going to write my ratios of my sides, those ratios are going to reduce down to the same thing. So just looking at this one, we'd have 2/3. Looking at this again, we're going to end up with 2/3. So, and all the ratios are going to end up being proportional because we are creating similar triangles there. So if we can get a closer point, there's going to be less reducing for us, but any point technically on the line that is defined is going to work. So now that I made a big mess of this, let's clean it all up because I don't need all that extra information. This is just to help you understand. Alright, so now our trig functions. So our sine. Sine is going to be y over r, and actually let me label these just so I don't try to do multiple things in my head. This was our x, this is our y, and this is our r. So for the sine, again, y over r, we're going to say -3 over radical 13. We're going to rationalize. Hopefully you can do some of this in your head. So we're going to say that that's going to be -3 radical 13 over 13. Cosine for theta is going to be x over r. So that's going to be -2 over radical 13. We can skip the rationalizing on this one because basically the same thing happens. So -2 radical 13 over 13. And then if I want the tangent, tangent's going to be r y over x, so -3 over -2, which just becomes a positive 3 over 2. And then we're going to take the reciprocals. So reciprocal of sine is cosecant. So we're going to flip over this version. So we're going to negative radical 13 over 3. Reciprocal for cosine is going to be secant. Again, I'm going to flip this version. So we're going to get a negative radical 13 over 2. And the reciprocal for tangent is going to be cotangent. And doesn't matter which one we flip. So we're going to end up with a positive 2/3. Okay? So if you're given the point that your terminal side passes through, then you're outright given your x and your y. You've got to use Pythagorean theorem to find r. If you're given that your line or that your terminal side is defined by a line, you want to do the same thing. Find a point that's on that line, other than the origin, because that's going to be where we're looking at the vertex of our angle anyway. So something other than the origin that is on your line, and that point will work for your x value and your y value. The rest of the process is the same. So again, here's one for you to try. Pause the video, see if you can do this. If you're not going to pause, then let's try this again. So we have this line. Again, I'm going to make a table to graph this. And I'm just going to pick my x's and y's, or pick my x's and figure out what my y's are based on this domain. So we're looking at x values that are greater than or equal to 0. So I'm going to definitely start at 0. If I plug a 0 in, 0 plus 2, y equal to 0, means that y has to be 0 as well. So we're going to be going through the origin. That's pretty much going to be standard. That's going to happen. Then I need another nice x value that's bigger than 0. So let me go back to this. If I subtract that x value over and then divide it by 2, then I can see a really nice x value to plug in, right? If I want it to be bigger than 0, like I don't want to put a 1 in because then I have to graph a half. That's no good. But if I put a 2 in, I can see that y is going to be 2 divided by 2, which would be a nice whole number, okay? Or if you wanted to pick something larger, like 6, you could definitely plug a 6 in. 6 divided by 2 would be 3, and you could use the point 6, 3. As long as your point is on your line, you're going to be fine. It's just if we pick the smaller one, then we have a little bit less reducing. Okay, so actually maybe I should have left some of that. Oops, forward. Let me leave this, just if you're coming back to it, like where did she get these numbers? So this is what I used, okay, to figure out. I plugged my 0, picked 0 for x, picked 2 for x, plugged it in, and figure out that the corresponding y values were 0 and 1. So let's make our picture. And again, if we have 0, 0, and then 2, 1, our x is bigger than 0, we're looking at quadrant 1. So we got 0, 0, and then 2, 1. If you really want to make your tick marks, I don't generally do it just because, look, see, I made them, and then my point is like way off. It's like my eyes don't work or something. Okay, so here is the triangle that we can create from this picture. Okay, so if this is a point on our line, oops, let me turn off the drawing tool. If this is a point on our line at 2, 1, then my x value is 2, my y value is 1, right? So the side of my triangles are now 2 and 1, and I can use Pythagorean theorem to figure out that missing side. So r squared is equal to 1 squared plus 2 squared. So that's 1 and 4, which is 5. So if r squared is equal to 5, r is going to be equal to the square root of 5. And now I have everything I need. Right? I have my value for r, again my value for x, my value for y. I can write all 6 trig functions. So the sine is y over r, so 1 over radical 5. Rationalizing this by multiplying by radical 5, we end up with radical 5 over 5. Cosine is going to be x over r, that's 2 over radical 5. So this would be 2 radical 5 over 5. Turned on my eraser. Tangent. Then we take our y over our x, so 1/2, nice and easy. And now our reciprocals. And maybe I should scooch this over just a smidge. So reciprocal for sine, that's going to be cosecant. So I'm going to flip over this version. That's going to be radical 5 over 1, which is just radical 5. Reciprocal for cosine's secant. Again, flip over this version. So that's going to be radical 5 over 2. And the reciprocal for tangent is going to be cotangent. So that's going to be 2 over 1, which is just 2. And there they are, all 6 trig functions. Okay? And we're going to look at a couple more, just again, basically doing the same thing, but given the information in a slightly different format. So for number 5, suppose that the angle theta, I don't feel like I'm missing a word, is in quadrant 3, and that tangent of theta is 8/5. Based on this information, we're going to be asked to find the values of the other 5 trig functions of theta. So we're looking at an angle in quadrant 3. Again, let's start by drawing this out. That actually looked pretty good, but I want to use my cheat tool. So in quadrant 3, I want an angle. Here's my angle, and it says, oh, let me go ahead and draw the triangle that's associated with this. So here is my triangle. Again, I'm looking at an angle in quadrant 3, so there's my angle, but the terminal side is in quadrant 3, so that triangle looks like this. Now, if they're telling us that the tangent is 8 over 5, then we have to understand, right? Tangent was a ratio of y over x. That means that the y value is going to be 8, and that the x value is going to be 5. Now, it's a positive when we're looking at the ratio, but because we're in quadrant 3, I know I'm going left 5 and down 8 to get there. That negative ends up becoming a positive when we write the ratio, but we have to make sure we account for those in our picture, because those negatives may impact the other trig ratios. Again, we're going to use Pythagorean theorem to find the missing side here, the radius. So r squared is going to equal negative 5 squared plus negative 8 squared. So we're looking at 25 and 64, which is going to be 89. So r is the square root of 89. Okay, can we simplify 89? Sorry, brain was going. I don't think so. So, let's see, I'm trying to think if anything goes into 89. Do we know? I should have played with this a little bit. Not 17, like 17 or something random is going to go in there. No. Okay, let's leave it. Radical 89. So that's going to be our radius length here. Again, now we have all the things we need to write our ratios. We got r, we have our x value, we have our y value. And again, counting for those negatives because they're going to impact the other 5 trig ratios that we have to find. So we are asked to find the rest. Let's go sine. Sine is going to be y over r, so negative 8 over radical 89, which would be negative 8 radical 89 over 89. Cosine, which is x over r, so negative 5 over radical 89. Rationalized, we get negative 5 radical 89 over 89. Tangent, we don't need to do because we already got tangent. That was given to us. We needed the other 5. So now we'll do the reciprocal here of sine is going to be cosecant. So let me flip that version. So we're looking at a negative radical 89 over 8. Reciprocal of cosine is going to be secant. I'm going to flip that version. So that's going to be a negative radical 89 over 5. And then cotangent, reciprocal of the tangent that we were given, would be 5/8. Okay, so we got one left. And again, if you are feeling pretty confident, you think you can handle this, then pause the video and give it a shot. Otherwise, again, we have the same thing we're trying to find. Not all the trig ratios in this case, it just says to find cosine and tangent, but we're given information a little bit differently, and I could have asked you to find any of the trig ratios. I'm just focusing on 2 here. So it says find cosine, find tangent, and here's what we're given. It says that the sine of our angle is negative radical 2 over 3, and it says that our cosine is greater than 0. So what does it mean for our cosine to be greater than 0? What kinds of numbers are greater than 0? Those are positive numbers. So we know that we have a positive cosine, and we know here that we have a negative value for sine. Now remember, the sines are the radius, or the y values over the radius. So this is implying that we have a negative y value, And then the cosines, those are the x values over the radius. So this is implying that we have a positive x value. The radius, being that length, is always going to be positive. So if we have a negative, it's got to be attached to the y value. And but if they're both positive, then obviously we're going to have positive. If like cosine was positive, they would have to both be positive. So again, radius always being negative, this tells us we have a negative x and a positive y. That's helpful because we know that we have positive x's and negative y's in quadrant 4. So that is a way for the information to tell us that we're looking at an angle in quadrant 4. So now let's sketch it out. So if we're looking at, let's use the cheat tool. Okay, so an angle in quadrant 4. Let's draw this out. And let's make the triangle. Let me cheat again. Make this look good if I can. Good grief. Okay, so here's our angle. Here's our triangle. Again, this is I should have been labeling all the right angles, but you can kind of see where they land, I am hoping. Okay, so if they're telling us that the sine is negative radical 2 over 2, then this is, remember, sine is a ratio of y over r. So I know the y value has to be negative radical 2, again, because we're going down, so that's where the negative is going to go, and the radius length is going to be 3. And now I can use Pythagorean theorem to find the missing side. It's just that we're not looking for the radius this time, we're looking for x. So the missing side is going to be x, let's say x squared plus negative radical 2 squared, the y squared, is equal to r squared, which is 3, so 3 squared. So a negative radical 2 squared is going to be a positive 2. This is going to be 9, which we'll have to subtract the 2 from, which will give us 7. So x is going to be a radical 7. So we're going to get a radical 7 here. So it's the same concept. We're using Pythagorean theorem. Just be careful because we're looking for x this time and not the radius. The radius was given. Alright, so now that we have all three pieces, again we have x, we have y, we have r, then we can figure out, in this case, the two ratios are asking us to find. So it's only asking for cosine of theta. Cosine is our x value divided by our radius, so that's going to be radical 7 divided by 3, and don't have to rationalize, how nice. And then tangent. Tangent is our y value over our x value. So our y value of negative radical 2 over our x value of radical 7. So we're going to have to multiply by, let me just go ahead and show the work, radical 7 to rationalize. That's going to give us a negative radical 14 in the numerator, and then just a 7 in the denominator. So negative radical 14 over 7. And we did it. Okay? So using those general forms of trig functions to find missing sides in a triangle, Pythagorean theorem, and then write all those ratios. Okay, so accounting for a radius length that isn't necessarily 1 or in that unit circle. Hopefully, I have given you enough variety in the problems for you to be successful in your homework, but as always, if you have any questions, feel free to reach out. Till next time, take care.